Our today's topic is variation of parameters. It's another method to solve higher order linear homogeneous differential equations with constant coefficients. We have solved the exact same type in the last lecture using undetermined coefficients. So, first thing we would like to know is what is the difference between the two methods. In undetermined coefficients, let's say our equation is a2 y double prime a1 y prime equals, and here we have g of x. Okay, the choice of g of x in undetermined coefficients is a polynomial, sine ax or cosine ax, and e power ax or bx. Undetermined coefficients can solve only these three kinds of functions. Only these three kinds of functions. Undetermined coefficients cannot solve tan ax, or secant ax, or any other, even for that matter 1 over x. Undetermined coefficients cannot solve these functions. So, variation of parameters can solve a bigger set of functions. I won't say that it can solve any function because it will depend on the integral we get within this method at the end. Okay? Sometimes we cannot solve the integral, so it will give us a partial solution, so to say. I will start with an example. I'll give the formulas within the example. Now, the example I'm going to take is from exercise 3.5, which is our next exercise in the course. Question number 1. The question is, well, once again, solve the given differential equation. Sometimes we mention the method in the question, sometimes we do not mention the method in the question. So we can easily figure out that the right hand side is secant x, so undetermined coefficients cannot be applied. Only variation of parameters can be applied. Right. So that is our equation, y double prime plus y equals secant x. First step is once again exactly the same as it was in undetermined coefficients. So first step is for yc. Our solution once again will be y equals yc plus yp, where yc is for the homogeneous part, yc is for the homogeneous part, homogeneous differential equation, and yp is for non-homogeneous part. Okay. For yc, we do exactly the same as we did in undetermined coefficients. Y double prime plus y equals 0. We write our auxiliary. Please be very careful, as I have mentioned already in undetermined coefficients, do not put an m for y. Okay? That gives m equals plus minus iota, and that means yc equals c1 cos of x, c2 sine of x. Right. Now for yp, here is where this method becomes different than the undetermined coefficients. But first step is there is some similarity though. We suppose yp once again, but the supposition is slightly different. We suppose that yp is u1 y1 plus u2 y2. What are y1 and y2? Right. It depends, this expression, the one I have just written, it depends on this solution here, the one we already know. Cos x is y1, cos x is y1, and sin x is y2 without the constants. Please note that it is without the constants. Okay? If it was a third order equation, then there would be a y3 as well. And then we write yp equals u1 y1 plus u2 y2 plus u3 y3 if it is a third order equation. But because this is a second order equation, it has two solutions, So we start with u1 y1 and plus u2 y2. In this expression, u1 y1 plus u2 y2, we already know y1 and y2 from our yc, but we don't know u1 and u2. Okay? We have to find u1 and u2. How do we find them? There is a formula given. That formula we can use, well, two formulas, of course, one for both. Formula is u1 prime, yes, it is in the form of derivative actually, u1 prime equals minus y2 f of x over w, and u2 prime equals y1 f of x over w. Two questions in the formula, very important. What is f of x? Well, we know already what is y1 and y2. They are here. y1 is cosine x and y2 is sine x coming from yc. Whatever is attached to c1 is y1. Whatever is attached to c2 is y2. In some questions, it can be e power x or anything else. Okay, x maybe or something. What is f of x and what is w? F of x, we used to call it g of x in undetermined coefficients, and here we are going to call it f of x. F of x is the function on the right hand side of the equation. Okay, this function secant x is our f of x. Okay, so in the formula we know y2, we know f of x. Now question is, what is w here? W is a matrix, is a determinant. It is written as W is written as, using again y1 and y2, y1, y2, y1 prime, y2 prime. Derivatives, y1 prime, y2 prime means derivatives. Okay, these are also derivatives. u1 prime means derivative of u1, not u1. We have to integrate this one to get u1, where y1 prime is actually dy1 by dx, and y2 prime is actually dy2 over dx. We know all the needed functions. We know y1 and y2. We know f of x. We can calculate w, put the value here, and calculate u1 prime and all that. Okay, let's start with that. I'll write all of them again here just for easy reference. So our y1 is cosine x, our y2 is sine x, and our f of x is secant x. Okay, right, u2 prime. First let's calculate w because we need it for both of them. W equals y1, y2, oops, not cosine x, y1 prime, y2 prime, which is equal to cosine x, sine x, derivative of cosine x, which is minus sine x, derivative of sine x, which is cos x, and that is equal to cos square x plus sine square x, and interestingly and luckily it is equal to 1. That will make our life very easy because this will go 1. Okay, u1 prime is equal to minus y2 f of x over w, which means minus y2 is sine x into secant x over 1, no need to write. What is minus sine x over secant x? Well, minus sine x over secant x, if we want to write, we can write minus sine x over cos x because secant x is 1 over cos x. u1 is integral of u1 prime. Okay, so that means it is minus sine x over cos x dx. That is clearly a log of cos x, because derivative of cos x is minus sin x, so we don't even need to adjust minus, it is already there. We don't put plus c here, okay, because this is particular solution. As you remember, in particular solution we did not put constants even for undetermined coefficients case. Okay, u2 prime is y1 f of x over w. Y1 is cos x into secant x over 1. Well, no need to write 1 actually. Cos x into secant x, well, secant x is 1 over cos x, so that becomes 1. That is even easier. So now u2 equals integral u2 prime dx, which means integral 1 dx, and that means x. That completes our yp, u1 y1 plus u2 y2, which is log of cos x, our u1, multiplied with y1, which is cos x, plus u2, which is x, multiplied with y2, which is sin x. And we can write y equals yc plus yp, c1 cos x, c2 sin x plus, I'll write cos x before, cos x into log of cos x, x sin x. Let us do one more question in the same style. Our next question is question number 8 from the same exercise. Y double prime minus 4y equals e raised power 2x over x. So that tells us our f of x is e raised power 2x over x. First of all, we find yc, and of yc we put this equal to 0, m square minus 4 equals 0, m equals 2 and minus 2, and yc equals c1 e raised power 2x, c2 e raised power minus 2x. That also tells us that our y1 is e raised power 2x and y2 is e raised power minus 2x. For yp, we write first the expression u1 y1 plus u2 y2. We know already what y1 and y2 are. And then we start with the formula minus y2 f of x over w, but first of course we have to calculate w. This is equal to e raised power 2x, e raised power minus 2x, 2 e raised power 2x minus 2 e raised power minus 2x, derivatives, okay, derivatives of the functions in the first row, and that would be equal to minus 2 e raised power 2x multiply e raised power minus 2x minus 2, again the same, 2x minus 2x, what do we get? Minus 2, and this is minus 4. Remember a very basic algebra rule that x power m multiply x power n equals m plus n. Okay, so e power 2x multiply e power minus 2x will be 2x minus 2x, which is 0, and becomes 1. E raised power 0 and becomes 1. Okay, right. So our w is minus 4. Now we can put the values into formulas for u1 prime and u2 prime. This will become minus y2, which is, do not change y1 and y2 after you have used them here. If you have used this as y1 and this as y2, keep them fixed. Although you can start with other way around, but keep them fixed once you have started. y2 is e raised power minus 2x. F of x was e raised power 2x over x, e raised power 2x over x, and over w is minus 4. Okay, so that gives plus 1 by 4. This is minus 2x and this is plus 2x. So once again, using the same rule, we get 1 over x, and u1 will be 1 by 4 integral 1 over x dx, which is 1 by 4 log of x. All right, u2 prime is plus y1 f of x over w, which would be e power 2x multiply e raised power 2x over x over minus 4. That would be minus 1 by 4 e raised power 4x over x, because now it is plus and plus. 2x plus 2x makes 4x. Okay? And u2 is interesting integral, which is e raised power 2x over dx. What is this integral? Anybody knows? Any formula that can work for this integral? I'm leaving this for you to solve because this is a very, very interesting integral. But also, interestingly again, we cannot solve this with the knowledge we have in this course. Okay, and I am going to leave it like that. Yp equals u1 y1. I'll write yc directly. Why not? No harm. This integral have no solution for our course. Okay, it does add, of course, it does have a solution in literature, but for our course we cannot solve it. Okay, y equals yc plus yp, that would become c1 e raised power 2x plus c2 e raised power minus 2x plus u1 y1, where u1 is plus 1 by 4 log of x into y1 is e power 2x. Don't cancel log and e, they are multiplied here. Plus u2 y2. Well, u2 is an integral. There is nothing we can do about it. I'll write the other part first. E raised power minus 2x divided by 4 integral e raised power 2x over x dx. Yes, we will use the integral as it is in the answer because we do not know the answer to it. You can ask a very genuine question here, that how would we know in exam whether the integral is solvable or not? Well, yes, that's a very good question. And the answer is most probably I'll give you integrals which are solvable. I just showed you the example to tell you, as I said in the start here, that undetermined coefficients can only solve polynomial sine, cos, and e power. Variation of parameters can solve a much bigger set of functions, but can it solve any function at all? Well, maybe for our course, not every function. As you can see, we don't know the answer to this thing, although we do know something about the equation. We know that yc is this, part of yp is this. This thing is still an integral, but that's how things work. Different methods have different limitations. Okay, they are good for something, they are not good for something. So that's how it works.